with more than two equations. We only are responsible for working with a two-equation system, and that's what this one is. 4x minus 3y equals 20, x plus 2y equals negative 6. Rather than having x and a y. And we know that no matter what the x value is in the first equation, it has to be the same in the second. So they give us some choices. The solution to the system of equations is an ordered pair if there's a solution. It could also be all real numbers if there's a solution, right? But if there's one solution, it's an ordered pair. In this case, the variables are x and y, and the ordered pair, the first number would represent the x, so the input, the x coordinate, and the y would represent the y value or the output, right? So we learned several ways to solve a system of equations by graphing, which we're not going to use, and by substitution or elimination. Those are the ways that we can solve them easiest algebraically. If we have a system of equations where one of the equations is solved for a variable, in other words, if this said x equals negative 2y minus 6, we might want to use substitution. My personal favorite is elimination almost no matter what, unless it's just a really simple substitution. Since neither of these equations are solved for x or y, the x's, the y's, and the constants are all lined up to make our work a little bit easier. We are going to use the process of the strategy of eliminating one of the variables, and then we can use the value of that variable to find the second. So if we're looking here, remember the strategy is add them vertically. 4x plus x is 5x. X's don't go away. Negative 3y plus 2y equals negative y. The y's don't go away. But the other part of elimination is we can't just add them to eliminate, but if we can't just add them, we can multiply one or both of the equations so we have opposite coefficients on one of the variables. So the easiest thing to do, this is a 4x. Is there something I can multiply this equation by so it would be the opposite of positive 4x? What can I multiply it by? Negative 4, that's right. So my first equation, I'm going to bring it over, and then I'm going to multiply everything in this equation by negative 4. So now when I add them, 4x plus negative 4x, or 4x minus 4x is 0. So my x's have been eliminated. Negative 3y minus 8y is negative 11y. 20 plus 24. So negative 3y plus negative 8 is probably a better way to think of it. So we're not subtracting this number. Now we have a one-step equation of multiplying negative 11 by y. So we're going to undo that multiplication by dividing. And now we know that y is negative 4. There is only one ordered pair that has a y value of negative 4. So we already know that our answer is B. And you could stop there. We can also confirm. And the way we can confirm that is we can take this y value and plug it back into one of our original equations and see, are we going to actually get 2 for that? So that's what we're going to do. And this is the easier one to work with. So we're going to take x plus 2, and that's 2 times y. We know our y is negative 4 now. And that equals negative 6. So this would be x minus 8 equals negative 6. And undo subtracting 8, we add 8. And so now we know that the x coordinate value is 2, and that is what we thought, right? So 2 negative 4 rather. Any questions on that system of equations? Okay. We're going to skip 30, it's a Venn diagram question. And we're going to look at this one. Lydia factors a trinomial, 3x squared plus 17 times x minus 6. Which one of these is one of the correct factors? So there can be two factors. One of these is a factor. This is a trinomial with a coefficient on that first term of 3. So the way we're going to factor this is by grouping. Now, if you remember, how many terms is the expression supposed to have if we factor by grouping? 4 terms, right? Ours only has 3, so we're going to rewrite it as a 4-term polynomial. Our first term always stays the same. Our last term always stays the same. And we're going to rewrite this 17x, positive 17x, as 2 terms and add them here. The way we figure out what those 2 terms are supposed to be, we're going to take a times c, right? So AC is negative 18. That's the product of our 2 terms, the coefficients on our 2 terms. So if it's a negative, what do the signs have to be? 2 positives, 2 negatives, or 1 of each? 1 of each. Now, the product has to be negative 18, but the sum has to be that positive 17. So what factors of negative 18 will give me a positive 17 if I add them? Yes. Which one's going to be positive, which one's going to be negative? 1 or 18? One's going to be positive or negative? No. We need a positive 17, so the 1's going to be negative, right? Because negative 1 times 18 is negative 18, and negative 1 plus 18 is positive 17. That makes sense, Keishan? Yeah? So now we're going to rewrite this as minus 1x plus 18x. And then we're going to factor by grouping, which means we're going to give ourselves groups. So 4 terms factored into 2 binomial factors. What's going to be my first term in this first factor? X. Very good. The greatest common factor of 3x squared and x is x. What's going to be the rest of this factor? It's going to be 6. The sign depends on this. Since this is a plus, it's a positive 6. Does that make sense to me? If that were a negative one, you would pull out a negative 6. How am I going to find this last factor? Yes, divide this first group by its greatest common factor, or we can divide the second group by its greatest common factor above. We've been doing it this way all year. We're going to keep doing that. So that's going to be 3x minus 1. So these are the 2 factors, but they only give us 1. We're going to pick the one that is a factor. Is it A, B, C, or D? Any questions on that one? Okay, so we're going to read number 32. A deli charges $5 for a sandwich and $2 for a drink. In one day, the deli made $230 by selling a total of 55 sandwiches and drinks. How many drinks were sold at the deli that day? Well, our unknown we know is going to be the number of drinks. Is going to be the number of drinks sold. But there's also another unknown. This is a system of equations problem again. If we looked at this problem, there are 2 equations we can write based on the information they give us. They tell us that all the sandwiches are $5 each. All of the drinks are $2 each. They tell us in one day the deli made $230 by selling a total of 55 sandwiches and drinks. So we really have 2 different sets of information here. So they made $230 by selling sandwiches and drinks. So while they don't ask us for the number of sandwiches, that is also a variable we need to define. Oh, I spelled sandwiches wrong. It's spelled this way. I gotta Google that later. I'm curious. All right. So let's look at this part of the sentence. A total of 55 sandwiches and drinks were sold. Can anybody give me an equation that we could write based on what we know from that part of that sentence? Beautiful. The number of drinks plus the number of sandwiches equals 55. That's what they tell us here. Selling a total. So we're going to add the number of drinks, the number of sandwiches, and that number altogether is 55. They also tell us that they sold, when they sold those 55 sandwiches, they made $230, right? So that is our other constant for our second equation. What's the other part of this equation going to look like? Remember, the cost of a number of items is the cost per item times the number you buy. Take sense, look at our variable, right? So the deli charges $5 for each sandwich. So if we buy 2 sandwiches, how much money does that cost? How much does that cost us? Right, we did 5 times the number of 2, right? If we don't know the number, then we use the variables we picked for that. So the drinks are $2, so 2 times the number of drinks plus $5 times the number of sandwiches equals altogether $230. That make sense? And so for this particular equation problem, so not only do we have to write the system, now we need to solve the system. We solved it before, we didn't have to write it. The other thing with this one is we don't actually have to solve for both variables. It asks us only to solve for the number of drinks. So if we only need to know how many drinks there are, then we can eliminate the s's, and then we don't have to solve for both. So what can I multiply one of these equations by to get rid of the s's? Anybody? I'll tell you, we need to multiply this one by something. What can I multiply this equation by to get rid of 5s? What plus 5s would equal 0? Yes, negative 5s plus 5s would be 0, so we multiply this all by negative 5. So we multiply this by negative 5b minus 5s equals negative 275. I'm going to bring this one down and add it to that original one, original second equation. Now when I add them, 5d minus 2d is negative 3d. Negative 5s plus 5s, I've eliminated my s's like I wanted to. Negative 275 plus 230 is negative 45. So now I can solve for d, and I'll know how many drinks they sold. How do I solve for d? How do we solve for d? Divide by negative 3. D equals 15. So d, or the number of drinks sold, is 15. If we wanted to know the number of sandwiches sold, we could plug d into here. 15 plus s is 55, or 55 minus 15. So we know there were 4 sandwiches sold. Any questions on that one? I'm going to let you catch up with me. So we have one more to do. So this question, 33. If Angela is going to graph the equation y equals 6 minus 3/4 x using the x and y intercept, which of these sets of ordered pairs represents the x and y intercepts that Angela will use to graph her equation? Well, first let's remember what are x and y intercepts. What are they? And how do we know if we see an ordered pair which is which? So then it's starting up a little coordinate plane. Put little tick marks on it. X-axis, y-axis. X-intercepts are points on the x-axis where the line crosses that axis. So let's pick a point. What is the ordered pair represented by that point there? What is the x-coordinate and y-coordinate of this ordered pair? Start at the origin, the left or right first. So right 3, positive 3. The y-coordinate is up or down. How far do we go up or down? 0. Okay? Let's look at this other point on the x-axis. So if a line went through that, that would be x-intercept. What is the ordered pair for that point? -1 and 0. So all x-intercepts, all x-intercepts will look like this. So I'll have a number for the x value, but they'll all have a 0 for the y. Let's look at the y-intercept. So any point that crosses the y-axis, any line that crosses the y-axis, that point where it crosses is the y-intercept. What's the ordered pair for this point? How far do we go left or right to get to that point? 0. And how far do we go up or down? 4. Up 4, which is positive. So that is the ordered pair for that point. What's the ordered pair for this point? How far do we go up or down? 0. And how far do we go down? So down is -2. So the y-intercept of any line will always have a 0 for the x-coordinate and some number for the y-coordinate. So we know that this is the y-intercept, this is an x-intercept. Y-intercept, x-intercept. Y-intercept, x-intercept. Okay? Now, how do I know which of these is the y-intercept of this equation? Well, we could take all 4 pairs and start plugging in to see if it would make that equation into statement. But we have an easier way we can do it. We learned multiple forms of a linear equation. Which form does this equation closely resemble closest? So it's not any of the forms we learned. It looks very much like one of the forms. Which form does this look a lot like? It looks a lot like y equals mx plus b. Or y equals the slope y-intercept form, right? So here, y equals 6 minus 3/4 x. If I want to write it in this form, all I have to do is switch these around. I'm not moving anything on the other side of the equal sign. So now I know, though I don't need it, I know that that's the slope, right? And we should know that that is the y-intercept. So if the y-intercept is 6, what does that ordered pair look like for a y-intercept? Yeah, so the number 6 is going to be here, and this would be 0, right? So the y-intercept of this line is 0, 6. So 0, -8, no. 0, -6, yes. 0, 6 here, I think that's right. And 0, 8, this is the only one that has a y-intercept of 0, 6. If this one has 0, 6, then we need to check their x-intercepts, right? But we don't have to do that. We have enough information right there to know that C would be our answer. Any questions on that? All right, anybody else got their yellow sheet to turn into me to choose your accent? Over there. There is more copies of there. If you need one, you could go get another one. At this point, I did put enough for one each, but people are absent and never got one. That'll be on them. How many did I do, baby? Yes, hurry up. You're at the 10 minutes right now. You gotta hurry. I'll got your time. 10:09. You can write them both when you get back. All right, so once you get this turned in, or if you want to hold on to it, you could hold on to it if you want to use it to study tonight, but you can put it in the basket if you don't want to do that. There is a hard digital copy in Canvas on the home page. Remember, you're reporting directly to your testing location.